Hi. In this video, I'll explain how the graph paper diagramming method can be used to diagram synchronous siteswaps where no more than one ball is in a hand at a time. In these siteswaps, if a ball is caught by a hand on a beat, that ball must be thrown by that hand on the same beat. Each throw must be an even height and can either be caught by the hand that made the throw, or it can cross to the opposite hand. Since both hands throw at the same time in synchronous siteswaps, if synchronous siteswaps are diagrammed the same way as asynchronous siteswaps, but with two hands throwing on the same beat, the lines of throws landing in the left and right hand at the same time will overlap, and it will be unclear which hand is throwing or catching which ball on a given beat. To avoid overlapping throws, and to make it clear which hand is throwing and catching, one hand can be shifted one horizontal line up or one vertical line to the right. I'll start with the method that shifts a hand vertically with the frame shown here. It has the height 0 line for the left hand as the bottom horizontal line. The height 0 line for the right hand is one line above the left hand's height 0. Then, each horizontal line alternates between the left and right hands. Since synchronous siteswaps can only have even-numbered throw heights, subsequent throw heights for the same hand increase by 2. Beats can also only be even-numbered, so every other beat is labeled with an even number from 0 to the period -2, and with the 0 repeated at the end. This frame is for a period 4 siteswap, so we have a 0, 2, and 0. Left and right hand throws on a given beat will start from the same vertical line. No throws will start on the vertical line between the labeled beats, so those vertical lines aren't labeled. The row that a throw starts from will have the number of beats later that the ball is thrown next as the number of the label, and then L or R as the letter of the label to show which hand is throwing. If a ball is thrown to the same hand, the throw will simply be drawn as a line 45 degrees down and to the right, continuing until it reaches a height 0 on a labeled beat. Like asynchronous siteswaps, it will get one beat closer to landing with each vertical line, but unlike asynchronous siteswaps, it can only land on even-numbered vertical lines, and can either land on the lowest horizontal line for the left hand, or the line above that for the right hand. I'll add regular height 4 throws to each beat, with each throw landing in the hand that threw the ball, to get the standard 4-ball synchronous fountain. We have the 4, 4, 4, 4. When I write the siteswap, I'll put the left hand throw on the left and the right hand throw on the right for each beat, with the left and right hand throws of each beat separated by a comma and grouped together in parentheses. Each throw from the left hand lands in the left hand, and each throw from the right hand lands in the right hand. I'll swap the hands that the left and right hand throws from beat 0 land in. To do this, I'll erase each line from beat 0 to the line after beat 0, so the throw still continues past that line and lands in the same place. Then I'll draw new lines from beat 0 to the line after beat 0, so that they connect to the location of the throw that will land in the opposite hand. When I write this siteswap, I'll add an X after the number for each throw that crosses. We have the 4X, 4X, 4, 4. Anytime a throw crosses, it will be drawn this way, so that the crossing is shown by the line from the beat of the throw to the first vertical line after that, which is always an unlabeled line. Then from that unlabeled vertical line, the throw line will always go 45 degrees down and to the right until it lands. Choosing to make the L's the lower horizontal lines and the R's the raised horizontal lines for each beat allows the shape of the capital letters L and R to be a reminder of where to draw the first line if it crosses. If it's an L, it will be drawn horizontally to the right, like the bottom of a capital L. If it's an R, it will be drawn down and to the right, like the line down and to the right on a capital R, only it will be drawn to the point 2 horizontal lines down instead of 1. So here we have the horizontal L and the diagonal R. Now I'll swap the right-hand throws on beats 0 and 2, starting by erasing the line from beat 0 to beat 2. Since the throw from the right hand on beat 0 crosses to the left hand, just erasing the line to beat 2 gives a left hand throw. The throw needs to be from the right hand, so I'll have to erase the line past beat 2 and then redraw it from the right hand as a crossing throw. This gives a 2x, which will be passed directly to the other hand like a 1 in an asynchronous siteswap. Since the right hand throw from beat 2 doesn't cross, I can just extend the line up and back to beat 0. We have the 4x6, 4, 2x. If we switched all the L's and R's in the labels, then it would change which hand catches and throws on each beat, but the throws within the frame wouldn't change, so the validity of the pattern would stay the same. Because of this, we can switch the left and right hand throws on every beat. Since 4x6, 4-2x is valid, 6-4x, 2x4 is also valid. We can remove a ball from the pattern by subtracting the period from a throw height, as long as the throw we subtract from is a non-crossing throw, or if the height will be 2 or greater after we subtract the period. I'll remove the height for a throw from the left hand on beat 2. Now beat 2 has no left-hand throw and no left-hand catch, so no ball will be caught in the left hand and no ball will be thrown from the left hand on beat 2. We get the 3-ball 4x6, 0, 2x. We can also add a ball by adding the period to a throw height. I'll add 4 to the right hand throw on beat 2. First I'll have to erase the crossing line, and then draw a diagonal line back to beat 2. Now I can extend that line back and to the left to the vertical line just after beat 2. If I were to continue all the way to beat 2, I'd reach the left hand on beat 2, but I'm adding to the right hand throw, so I'll need a crossing line. To get the crossing line right, we can remember from the capital R that the line needs to go down and to the right, so we'll start on the right hand height above. Now we have the 4-ball 4x6, 0, 6x. Anytime we add or subtract the period from a non-crossing throw, we get another non-crossing throw from the same hand, which can possibly be a height 0. If we add or subtract the period from a crossing throw, we'll end up with another crossing throw from the same hand, unless, for example, we try to subtract 4 from the 4x from the left hand. In this case, we end up at the 0R. Now, no ball is caught by the right hand on beat 0, but since originally a line had ended at the right hand on beat 0, a line had also started from the right hand on beat 0 in order to have a valid siteswap. This is the height 6 throw. We end up with a throw without a catch in the right hand on beat 0, so we no longer have a valid siteswap. Anytime we have a crossing throw that's a height equal to the period, we won't be able to remove a ball by subtracting the period from that throw height. Now I'll show the method that shifts a hand horizontally with the frame shown here. Inside the frame, it will look just like asynchronous siteswaps, with throw lines always going 45 degrees down and to the right, but the labels will be different, so the throw lines will have a different meaning. While the vertical shift method moved the right hand throws and catches one horizontal line up to separate the left and right hand, this method will move the right hand throws and catches one vertical line to the right. This means that time will have to be represented by two vertical lines at once, one for the left hand and one for the right hand. The vertical lines are labeled in pairs, starting with a 0L and a 0R, and each subsequent pair has 2 added to the beat number up to the period -2. Then a single 0L is added at the end to show where the pattern starts again. The throw heights are labeled based on where the throw needs to start in order to land in a particular hand a given number of beats later. A throw from any even-numbered horizontal line will land back in the same hand. The first height will be labeled 0, and then every other line will have the next even number for its label. Since these labels will be the same for both hands, the label will go in the middle of the vertical lines representing the left and right hands. Here we have 0, 2, 4, and 6. If a throw will cross from the left hand to the right hand, then since the right hand is one vertical line to the right of the left hand, the throw will have to move one more vertical line to the right to get there. This means the left hand crossing throw will have to start one horizontal line higher to reach the right hand on the same beat. Crossing throw heights will have an X added to the number. Here for the left hand, we have the 2X, 4X, and 6X. If a throw will cross from the right hand to the left hand, then since the left hand is one vertical line to the left of the right hand, the throw will have to move one less vertical line to the right to get there. This means right hand crossing throws will need to start one horizontal line lower to land in the left hand on the same beat. Here we have the 2X, 4X, and 6X. I'll add non-crossing height 4 throws to get the standard 4-ball synchronous fountain. We have the 4-4, 4-4. Like before, I'll swap the right and left hand throws on beat 0. This will be easier than it was with the vertical shift method because no lines will deviate from the standard 45-degree line, and I won't have to erase anything beyond the beat that I'm swapping to. So now we have the 4x, 4x, 4, 4. Now I'll swap the right-hand throws on beats 0 and 2. We have the 4x, 6, 4, 2x. With a horizontally shifted diagram, we can relabel the throw heights and get a corresponding asynchronous siteswap. This demonstrates what's known as the slide property, which is a property of siteswaps that allows one hand to slide in time to go between synchronous and asynchronous siteswaps. The asynchronous siteswap needs to have an even period for this to work. I'll add the height labels for asynchronous siteswaps to the right of the diagram, and I'll add beat labels for asynchronous siteswaps above the diagram. Here, the corresponding asynchronous siteswap is the 5, 6, 4, 1. We can also get the corresponding asynchronous siteswap numerically by adding 1 to the left-hand crossing throws and removing the x, subtracting 1 from the right-hand crossing throws and removing the x, and keeping the non-crossing throws as they are. The left-hand 4x throw has 1 added and the x removed to give a 5. The right-hand 6 stays the same. The left-hand 4 stays the same. And the right-hand 2x has 1 subtracted and the x removed to give a 1. If the left hand for each beat is labeled to the left, and the right hand is labeled to the right, then the capital L and capital R can be used to remember which hand has 1 added to the height of crossing throws, and which hand has 1 subtracted from the height of crossing throws when we're finding the corresponding asynchronous siteswap from a synchronous siteswap. Since synchronous siteswaps have both hands throwing at the same time, we can think of the throws from both hands as being together in time, drawn as a single vertical line. Since asynchronous siteswaps have hands throwing at different times, we can think of the throws as being separated in time, drawn as 2 separate vertical lines. Then, to go from a synchronous to an asynchronous siteswap, we need to separate the throws, so we can think of the beats separating into 2 lines, with 1 moving to the left for the left hand and 1 moving to the right for the right hand. When the left hand separates, we can then think of a point following left along the L, starting along the horizontal part of the L, and then moving up when it reaches the vertical line in the L. Since it moves up, we add 1 to the height. When the right hand separates, we can think of a point moving to the right, and then moving down and to the right along the diagonal part of the R. Since it moves down, we subtract 1. To get the corresponding synchronous siteswap from an asynchronous siteswap, we do the opposite. The beats are apart in an asynchronous siteswap, so 2 vertical lines will represent the time that each hand throws, and they need to be squeezed together to become 1 line for a synchronous siteswap. The left-hand line moves to the right, and the right-hand line moves to the left to meet at the middle. For the L, we can think of a point starting at the top left and moving down along the vertical part of the L before moving to the right along the horizontal part of the L to meet the right-hand line. Since it moves down, we subtract 1 from the left-hand throw height. For the R, we can think of a point starting at the bottom right of the diagonal part of the R, and then moving up and to the left along the diagonal line before moving to the left. Since it moves up, we add 1. Since the 5641 is a 4-ball asynchronous siteswap, it has a 3-ball height 7 inversion. To find this, I'll reverse the order and subtract each height from 7. So we have the 6312. Since odd height throws cross, to convert this asynchronous siteswap to a synchronous siteswap, one needs to be subtracted from any left-hand odd height throw, and an X needs to be added, and one needs to be added to any right-hand odd height throw, and an X needs to be added. To convert the 6312 to a synchronous siteswap, we would add 1 to the right-hand 3 and add an X, and subtract 1 from the left-hand 0 and add an X. So we would get a 4X for the right-hand throw here, and a 0X for the left-hand throw. And we would keep the 6 and the 2. The 0x that we get creates a problem. The height 1 throw from the left hand had previously landed in the right hand 1 beat after, so the right hand had a catch on that beat. That means in order for the siteswap to have been valid, the right hand also had to have a throw on that beat. That throw from the right hand on that beat can't have become a 0, because we only add to right-hand throws when going from asynchronous to synchronous siteswaps. So the 0x from the left hand means that a beat has a throw from the right hand without a catch, so the synchronous siteswap has to be invalid. This makes a 0x impossible. So anytime a left-hand throw has a 1 in an asynchronous siteswap, that siteswap won't have a corresponding synchronous siteswap. We can see in the diagram that the label that would have been a 0x has been left out. Anytime a right-hand throw has a corresponding throw of the maximum height, the throw height will exceed the maximum height since 1 is added, so while the corresponding synchronous siteswap will still be valid, if we want to stay within a given maximum height, then we won't want to include these siteswaps. Because of this, I left out the label that would have been an 8x from the right hand. Switching hands for the 4x, 6, 4, 2x gives the 6, 4x, 2x, 4. To go from this synchronous siteswap to the corresponding asynchronous siteswap, for the right hand 4x, we subtract 1 to get a 3 and remove the x. We add 1 to the left hand 2x and remove the x to get a 3. And we keep the left hand 6 and the right hand 4. So we have the 6, 3, 3, 4. I'll find the height 7 inversion for this. Subtracting 4 from 7, we get a 3. Subtracting 3 from 7, we get a 4. Subtracting 3 from 7, we get another 4. And subtracting 6 from 7, we get a 1. So we have the 3, 4, 4, 1. To get the corresponding synchronous siteswap, we subtract 1 from the left hand 3 and add an x to get a 2x. We add 1 to the right hand 1 and add an x to get a 2x. And we keep the right hand 4 and the left hand 4. We get the 2x, 4, 4, 2x. If we start the 6, 3, 3, 4 one beat later, we'll get the 3, 3, 4, 6, and the hands will be switched. To get the corresponding synchronous siteswap, we'll subtract 1 from the left-hand 3 and add an x to get a 2x. We'll add 1 to the right-hand 3 to get a 4x. And we'll keep the 4 and the 6. The 6334 and the 3346 are basically the same siteswap but mirrored, but the corresponding 6-4x, 2x4, and 2x4x, 4-6 are completely different siteswaps. For many asynchronous siteswaps, we can get 2 corresponding synchronous siteswaps by starting a beat later. However, if there's a height 1 throw in one of the siteswaps, we'll only get 1 corresponding siteswap. For example, if we start 1 beat later in the 3-4-4-1, we get the 4-4-1-3. This has a height 1 throw from the left hand, so it doesn't have a corresponding synchronous siteswap. Vertically and horizontally shifted diagrams each have advantages and disadvantages. In general, since vertically shifted diagrams only use one vertical line to represent time, they can make an individual siteswap easier to follow, while horizontally shifted diagrams split time into 2 vertical lines. Horizontally shifted diagrams only use 45-degree diagonal lines for throws, like asynchronous siteswap diagrams, and because of this, they can make it easier to show the relationships between different siteswaps, while vertically shifted diagrams don't stick to diagonal lines. This concludes this video. I hope it's helped improve your understanding of synchronous siteswaps.